Alright, this is going to be an introduction to trigonometry and kind of our first step into actual trigonometry, and we're going to talk about the special ratios. Now, in order to talk about special ratios, we need to define here two key vocabulary words that we haven't really talked about yet, and we need to have a right triangle. So we're going to start with our right triangle ABC, and we have our right angle here at B, and we're going to label three sides: an opposite side, an adjacent side, and a hypotenuse, all according to angle A. So what I like to do is I like to label angle A, and the first side I like to pick out of a triangle is always the hypotenuse, because no matter what angle we're looking at, I always know where it is, because we've spoken about that our hypotenuse is always opposite the right angle. So this side AC is going to be our hypotenuse. Now, opposite and adjacent are two new words that we haven't really talked about yet, but an opposite side is exactly what it sounds like. It is going to be the side that is opposite of angle A. So the side that is not touching angle A, or the way I like to look at it is the two letters that don't involve angle A, is going to be our opposite side. So our opposite side here is going to be C to B. And then the last one is our adjacent side. Now, adjacent is just a fancy word for next to. So which side is directly next to angle A? Is we're going to use this side down here as A to B. So this is going to be our adjacent side. Now, I know this may seem weird at first, just labeling these three sides of a triangle, but I'm trying to build this up into a different question so that you guys can see, where I'm going to get the information from. So you should be able to label these three sides, opposite, adjacent, and hypotenuse, based on angle A, or based on angle C, depending on what the question's asking. So this is just an example of according to angle A. Our first example we're going to work on here is going to have some numbers in it just to make things a little bit clearer. So this question reads, according to theta, okay, this is just a Greek letter that we use to label angles, and as you see it's down here. We're going to label our opposite, our adjacent, and our hypotenuse. So again, first one I like to look for is our hypotenuse, which we know is always either across from the right angle, or it's the largest of the three sides. So I just like to mark my right angle and mark my hypotenuse here. All right, the next one that I think is the easiest, or at least the easiest one to do next, is the opposite. So the opposite angle is going to be across or not touching the angle that we're dealing with. So the opposite side is going to be the 5. So we will label that opposite. And then what's nice is the last one we don't even have to think about because it's the only one left. 12 has to be our adjacent side. Now, one way I like to organize this information, just to make life a little bit easier, is I like to put my angle here, and I like to make a little brace map with O, A, and H, and just fill in the numbers wherever applicable. So the opposite side is 5, the adjacent side is 12, and the hypotenuse is 13. Now, this part is extremely important, and you'll see why when we get to our last example and kind of what the actual trigonometric ratios are. All right? So just be able to, given an angle, angle theta, be able to label your opposite, adjacent, and hypotenuse. All right, this is where it starts to get a little tricky, and we start to get into some things that you guys may not have seen before. So there are three ratios that we're going to work with. The first one is called the sine ratio. Now, these ratios are always going to have an angle in here. So this always is going to represent an angle. And the sine of any angle in a right triangle is going to be equal to the opposite side over the hypotenuse. All right, so the sine of any angle is the opposite side over the hypotenuse. Now, because we have a hypotenuse, this has to be in a right triangle. All right. The second ratio that we deal with is the cosine, again, of an angle. This one is going to be equal to the adjacent side over the hypotenuse. All right. And the last one is our tangent function, which is going to be the opposite side over the adjacent side. Now, you may have seen these three things on the calculator, but what we're going to do with these is we're going to learn how to set up some equations using these exact ratios, okay, these three ratios, given a right triangle. Now, a helpful way to remember this is we call it SOHCAHTOA. So the sine of the opposite over the hypotenuse, the cosine, the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. So we call this SOHCAHTOA. This is one helpful acronym that will help us remember and memorize our trigonometric ratios. Our last example is going to put everything together that we talked about in this entire video. So it's asking us to find out what the sine of t is, the cosine of t, and the tangent of t. Now notice that all three of these are dealing with angle t. So we're going to start by looking down here at angle t. And like I said, what I like to do is I like to make a brace map based on angle t, what my opposite, my adjacent, and my hypotenuse is. So the hypotenuse of this triangle doesn't really matter what angle t is, but we know that the hypotenuse is going to be across from that right angle, which is going to be 25. Now the opposite side is going to be across from angle t, so we know that's going to be the 7, and then the one left over has to be my adjacent side. So now once I get this map filled out, and I have 7 as the opposite, 24 is the adjacent, and 25 is the hypotenuse, I'm just going to fill out the ratios that we talked about up here. Okay, so I know that the sine function of any angle, but we're using angle t, is the opposite side over the hypotenuse. So all I need to do is take my opposite, my hypotenuse, and make a fraction, 7 over 25. So my sine of t equals 7 over 25. I'm going to do the same thing for cosine and tangent. So my cosine of t is my adjacent over hypotenuse, which is 24 over 25. So my cosine of t is 24 over 25. And then lastly, I'm going to do the same thing for my tangent. So my tangent of angle t is my opposite side over my adjacent side. So that's going to be 7 over 24. And my tan of t is 7 over 24. So these would be your 3 answers. Right? So based on these 3 or 4 parts that we went over, the first thing you need to do when you're asked a question like this is figure out which angle you want to create this brace map for. And you might have some questions where you have to do it for more than one angle, so you might have to do angle T and angle C. Right? The next thing that we do is we figure out what's my opposite, what's my adjacent, what's my hypotenuse. That's going to allow me to use sine, cosine, and tangent because I'll have all 3 of these numbers. And then from there, you just plug in the necessary information to get your 3 ratios that you need. We're going to go over some more examples like this in class, but this is the very, very beginning of trigonometry and the basics that you have to be able to start with in order to do these types of questions.